In this lesson, we're going to discuss energy. We'll learn about the two main types of mechanical energy, gravitational potential energy and kinetic energy. We'll talk about the others as well, and we'll do some practice problems. Some key vocab here: energy, which is the ability to do work; potential, stored energy; kinetic, moving energy; thermal, heat energy; radiant, like heat and light, it radiates outwards, it goes outwards, so that's something else; and mechanical energy, in this case the total mechanical energy between potential and kinetic. Another way, simple way, is saying total energy, and of course we'll get to that later as well. So what is energy? As I mentioned, it's the ability to do work. Just like work, like we did in the previous lesson, the unit is joules, so we'll use the same unit for this. Another way to think about it is energy is a measure of how much fuel is contained within something. If you have a falafel which has 100 calories, that means 100 calories worth of energy, or 100 joules worth of energy that you can use to do some work. Here are lots of different types of energy: electrical, heat, light, sound, chemical, perhaps from batteries, kinetic, potential, and even nuclear. These are all the different types of energies that we can have. You can change. You can get electrical energy into heat if you wanted to do that. Like a heater, a hairdryer, and whatnot. You can put electrical into sound, like in a speaker. You can do chemical into sound, like a battery sound working in a speaker. You can change and transfer energy from one form to another. So a little table with everything. So radiant energy, like light and heat, coming from the sun, bulbs of fire; electrical energy coming from a generator. Batteries provide us electrical energy, of course. They will store chemical energy inside, and it will be electrical energy coming out for us to use to power circuits and things. Nuclear energy comes from the nucleus of atoms. That has a lot of energy in that one. Power plants, or even inside the sun, actually, it's got nuclear energy too. Mechanical, two main types: kinetic and potential. We have types of potential: gravity, chemical, elastic, like with a spring or something, but we're just going to focus on kinetic energy and gravitational energy. These are the two main ones: moving objects and storing energy. This is gravity, which we discussed previously as well. You have a height, so you're going to raise an object and you will store more energy the higher an object is. So we know that work done when you move an object, E was F times D. And if you lift an object against gravity, well, then you have potential energy. So that force times distance becomes mg. W equals mg. Remember that? Mg times h. There's a little triangle there. E is mgh. So this is the formula for the energy, potential. So potential energy. You can write it as PE if you like as well. So here's an example: a mass of 7 kilograms, 4 meters above. If the acceleration of gravity is 10, I know we're supposed to use 9.8, but just for this example, to keep it simple, we'll just use 10. So the information we have is the mass, the height, and the gravity. We need the potential energy. So we can solve it. mgh, 7 times 10 times 4, gives us 280 joules of energy. A quick tip in our formula, you have to write this, then you have to write this, and then you write this. Formula, numbers, answer. This is how you answer questions in an exam to get full marks. You must have all three steps. Kinetic energy is the work done in moving something, so giving it a velocity. The formula for that is a little bit different. It's Ek equals a half mv squared. A half times the mass times the v squared. Only the velocity is squared. So here's an example. 100 kilogram rugby player is running at 6 meters per second. What is his kinetic energy? So we'll do a half mv squared. A half times 100 times 6 squared will give me 1,800 joules. Another example here is if a biker is moving at 12 meters per second, his kinetic energy is 3,600. Find the mass. So now we have the energy. We need to find the mass. Okay, so we'll take our formula and we can rearrange I don't know why that's black. 1 over 2. So EKKE, like I said, you can write it as you like. You could do 3,600 times a half mv squared. You can do shift calc, or you can rearrange the formula. So 12 squared, of course, is 144. Then you will just divide, there is a half here, by the way. Then you will divide by 144, and you will get your answer of 50. So there's a lot of extra steps. You could just do 3,600 divided by 144, and you will get 50 kilograms for the mass. And if you want to calculate the speed, you can do the same thing. You have your little formula, half mv squared. Again, this is for some reason black, a half mv squared, and shift calc, or rearrange the formula and get yourself your v. Of course, once you have the v squared, you have to do the square root, because we do not want v squared, we want v. So we'll do the square root of 36 to get the answer, which becomes 6 meters per second. Thank you.